Good afternoon and welcome. My name is Ken Goodman. I direct the University of Miami's Institute for Bioethics and our ethics programs, but more particularly for today's purposes, have the privilege of directing the program in data ethics and society for the Institute for Data Science and Computing. Fortunately, Professor Tsanaremus had the insight to make sure that IDISC had such an entity, and our part of our data science series continues today with a real privilege and a real treat. One of the things that IDISC has done, and I think it's done it really well, is to plug us into colleagues from around the world. And Professor Fayad comes to us from the Icahn School of Medicine at Mount Sinai in New York, where his work over the past, if I say it's too many decades, it makes you sound old, right? Okay. His work in cardiology and immunotherapy and applying all of that, including nanotechnology and a number of different digital tools, is helping to transform the way we metabolize information in the service of patient health. That includes both M-health, E-health, D-health, for whatever that would be, but also the very use of information technology in a plenary way to try and improve the health of populations, of individuals and of populations. His work has actually some of us get to wade in different ponds. You seem to be truly amphibious when it comes to cardiology, when it comes to nanotechnology, when it comes to immunotherapy and so forth. And so against that background, it is my distinct privilege to welcome Dr. Fayad, who's going to lead us in today's Data Citizens presentation. Afterward, we'll have time for some questions and an exchange. Professor Dr. Fayad.
Thank you so much.
I think now we shall share the screen and.
Okay, thank you so much for this. It's such a pleasure to be here attending this. My only regret is my daughter, who attends the university as a student, is not here. She is at a semester abroad in Barcelona. But definitely, miss not seeing her on this beautiful campus, since we hear a lot about it at home all the time, and obviously through my visits here. And it has been an incredible visit. I want to thank Provost Jeff Dirk, who is really one of my, I guess, heroes since I was a graduate student. I met him, and we remained in touch when he was working in the space of imaging, but also obviously admiring a lot of the work that he has done here for this great university, and obviously the new friends that he helped me make today and hopefully in the future. It has been a great visit. It's great to be on a campus, not being that beautiful. I envy you, but also to see the energy. I really see here, not only from the leadership of the Institute of Data Science and the other faculty member, but many of the junior faculty members and others that have been recruited, to lead these efforts, which I really congratulate you on putting this together. So the future is extremely bright for you guys, and I hope that this opens up doors for us to collaborate and to work together on important problems as you are tackling. So my talk is really going to, bridge a lot of some of the recent thoughts and work and story that I have been, doing in collaboration with a lot of people, and giving you a little bit of a flavor, where we are heading, trying to push these ideas. I am very interested, and not only from a personal point of view, which you will see here, so I apologize for my injecting some personal aspect into it, but I'm very interested in the exposure that we get through lifestyle, environmental, obviously, and biological determinant. All these are obviously affecting our health, and these are all stressors. We know quite a bit about genetics and genomics. Nick have been a leader with his work in the space of this, but there are other aspects that we can appreciate more and more today. Obviously, the environmental impact, which I think also you are leaders in the space looking at this, and other lifestyle aspect. These are all determinants, and we need to start teasing them out, in my view, not only to look at chronic diseases today, but also to look at it into the lifespan and helping hopefully find ways that we can push this and improve our lifespan as well as health span. So we want people to live longer and live a healthy for a very long time. That I hope that some of the concepts that I'm going to talk about here, although they are early, some of them may sound naive. There's a lot of work that needs to be done, and especially in reality of bringing this to our healthcare delivery system. But at least it will challenge us all to try to, push into that direction. But a lot to be done. What we also have started to appreciate, and I became obviously very much aware of it. My work has been always in the field of cardiovascular disease, focusing on the heart and the blood vessels. But more and more, in the space of even cardiology, we started to appreciate the interconnection between cardiovascular disease and the other organs. Very much appreciated both biologically as well as clinically today, the heart-brain axis and how this is driven. And we are now mechanistically have a very strong understanding of these pathways and their interconnection, and also ways we can intervene on the disease itself that helps, either prevent somebody from having a myocardial infarction or a stroke. We hear a lot about the brain-gut axis. I mean, the microbiome has been well, I will say, advertised and well recognized, and we are understanding better and better how it is affecting that aspect. And then recently, this is a paper, I think, published in either November or December of 2022, last year in Science, that's looking at the heart-liver axis now, where they discovered a new clotting factors made in the liver that protects the heart from heart failure. So so moving away from, this will take a couple of clicks, sorry. So moving now from this isolated or reductionist view of medicine, of where we focused initially on one organ, and I would say, clinical medicine continues to be practiced this way, but however, clinical programs are becoming more and more integrated. People, I mean, at least, the major centers, including the medical center here in Miami, where a cardiovascular patient walks into the clinic to see a cardiologist. There's also looking at it from a neurological point of view, and they are working with neurologists and stroke expert, as well as other expert in the other medical areas. Research also is moving from people focused on one organ to this organ and system. It's still very challenging, I will say, and I think has it to do not with the science, maybe has to do with how research is funded. It's still isolated. If you look at the NIH itself, it's very much in an organ and disease-based institutes rather than institute that are looking at the whole aspect. But there are incredible effort at the NIH, and I give credit to obviously leadership there, and Helen Langevin, who is at the National Complementary Institute. That is her strategic plan of their institute, although she doesn't have a lot of money, is to push the aspect of whole person research. And this is actually from one of her talks and review paper, where she's challenging the researchers to look at the connections between organs, which I showed you how important it is, but also start looking at it from a multiple direction, from the basic all the way to the whole human, even community. And this place is also very strong in community medicine and science. So I hope that behind this strategic thinking, we will all have enough resources to be able to do this. I do feel from a technological point of view, and this is really maybe the take-home message of my talk, is that we are beginning to collect tools to be able to tackle these problems. So that's why I think we all need to, hopefully there'll be many people inspired to push these aspects. We've heard a lot about personalized medicine. I mean, Nick can talk about this, from his previous work and when this came along, but more and more is being recognized. Obviously, genetic data has been the leader initially in aspect of personalized medicine, but more and more now, as I mentioned, what I introduced you to or talked is about the environmental factors that need to be put into aspect. This is something that resonates quite a bit with me because, we collect, I'm an imager by training and by nature or by work. And imaging has been ignored. It's a very powerful tool and has not been integrated into this data collection. So we have a lot more work, but at least it's starting to be recognized today how important it is that we move into that aspect. So we should not ignore this aspect. The other aspect which I just mentioned also, that we are now in possession of multiple tools to be able to do this. Multimodal collection, both from the clinical point of view, at least in clinical care, we have brought in, maybe if physicians in the room, they won't like that too much because they've been hassled by medical record and the difficulty and the burden it has on physician and care. However, it is here to stay. Every medical center, although in the United States, we're still fragmented. We're not like other European countries or other medical system where we have a national medical record. But at least we are able in one institution have a medical record that are able to be leveraged. This is how care is being delivered. And the other aspect is that clinical research is also being enabled because of these new recent tools. Many discoveries, many interesting questions, many hypothesis-driven things have been enabled today because of the way we are able to integrate data. A lot of work needs to be done in this space. We were just talking about how dirty the medical notes are, how much time data scientists are spending to clean data rather than to do real science in a way. And not all modalities are being put together. And that, I think, is one of the tasks that we have on our hand, is to hope that we can bring these data lakes together to be able to do and to get into these discoveries. So this is a very important aspect, which will not be solved tomorrow. But it's going to require also a lot of resources to do this. But at least it is put on the table today. People are thinking about it. For example, we and others have, put together data lakes, which mean, bringing data that's coming in clinically that is not only available to look at, let's say, population health, but also being able to be leveraged for discovery. I am responsible at Mount Sinai to put together the imaging data lake. We produce over 1.5 million imaging studies a year. At Mount Sinai, we have currently 1.2 petabytes of data that is being leveraged retrospectively and prospectively because we are digitized in radiology. That's actually one of the advantages we have. I know from my colleague in pathology, they are starting to get into that. That's a challenging, they are challenged this way. So we are starting to we already have put together the first version of the Imaging Research Warehouse. We are now in development of version 2.0, where we're starting to integrate, other new tools into it, especially in the aspect of curation, metadata curation, and then obviously making it ready for AI and ML development, and then deployment into the clinic. This is something that, in a way, was not on the table before. But now more and more we recognize how important it is, and that's why we're working throughout that direction. The other aspect, obviously, in radiology, and I don't have to tell you here that how the impact of AI methodology has been with multiple examples. I think the most number of startups, with FDA-approved product, it doesn't mean much because I don't think most of them is useful or will survive, but they are pushing that space very much. We obviously in clinical radiology, I know because I work with my colleague in clinical, that we have many tools that have been brought to the table. Some of them are being used clinically. Some of them are still need validation. And you have Yelena here and her effort and working into ways to figure out what's the best way to deploy these tools. More work to be done, but the science is extremely rich. One example, I was speaking with David of one of my faculty, one of my students, Shiyan May, who's now a junior or postdoc and junior faculty member in my group. She has put together the RAD ImageNet, which is today over 5 million multimodal imaging data set, where we can train, instead of using ImageNet, which is dogs and cats to train our models, we now are training on true radiology data. I think, and we put this in the public domain to hope to bring this to the next level. And she's already demonstrated how impactful this available data set could be. And we've also seen many groups that have adopted and started to use this modeling this data set to do this. And we plan to continue to augment this. But David can obviously say that there's a lot of work to be done there, and I appreciate that, and I know that for sure. So the tools in terms of crunching the data is here now, and that's why you have the groups here working hard into this space. And the other aspect that really COVID challenged us in a way to think about quick deployment into the clinic. And we created an infrastructure, as well as many people now, because we were forced to do this. Mount Sinai has been hit, by COVID. We had on a daily basis over 2,000 patients at the hospital. Our hospital became a COVID hospital. We even had a hospital in Central Park with the tents, as you recall, these very sad pictures of how to do this. So this challenged us, to put together ways to be able to take the tools that we develop from a research point of view and make a selection of which are the ones that are mature enough, or at least are urgent enough to be tested, to put them now across what we call across the aisle, to bring them to the clinical data science group to do deployment, testing and deployment. Yelena will say that there's a lot more to be done here. We really hope that there will be, guidelines and pathways to help us do this. But operationally, I do think all of us need to be prepared to be able to do this. And I'm not only speaking, from imaging point of view, we're talking about multimodal data. Everything I'm speaking here is very much multimodal oriented. Not all of them are mature to the same level, obviously, you can imagine. The other aspect, and this is what I hope maybe to challenge the group here and to potentially create some collaboration, is how can we now create an infrastructure or a platform? Let's say, because it will be an app-based type of application where we can collect and ingest multimodal data to be able to do whole person research. This is really a concept. We have started to build some of these modules, but we currently lack a way to do this at scale. And we're hoping that we are able to attract some funding to put this together. And the idea is that every subject that you're able to bring into a study, you can think about the All of Us study by the NIH, but it's also limited. There's no imaging data being collected there. And it's really frustrating. I understand, that there's not enough money to do this, but it's a little bit short-sighted, I have to say, from the NIH to deploy studies like this and not utilize, all the power that you can get. Imaging is here to stay. I mean, people are getting imaging encounters all the time. Most of you have had an imaging encounter for one reason or another. You broke your leg, you had to be diagnosed with something, you did a routine physical or routine screening, etc. This has not been leveraged, and it's upsetting. But maybe if the tools are available to ingest this data and to harmonize or to create, to bring that data into one single platform for ease use, maybe that will be adopted. The other aspect I like here, but I was inspired very much by what you're doing, is the environmental aspect that you create now, hopefully in the future, sensor technology that's fully embedded and integrated in your daily life. I'm not talking about these kind of sensors. I'm talking about embedding them as you are doing with your architecture department and the Data Institute, the integrate. So that also needs to be added to that platform. One of the concepts of why would you do something like this? I mean, we can talk about not chronic disease-wise. Let's talk about healthy. We all are born, maybe, healthy, or some people born with some genetic defect, but our trajectory of health and lifespan and health span changes. It's not something that is fixed over time. It is extremely dynamic. And we have a very poor understanding of the trajectory of health. We know, risk factors. We know, what would be maybe the mortality, morbidity in certain type of diseases. But we have a very, very, I think, rudimentary understanding of what healthy is. Nick and I talked about, obesity versus lean. We focus a lot on this trait, obesity. But do we have a good understanding of why certain people are not obese and how they are able to live this way? So there's a lot to be learned like this. We also this will hopefully create a way, if you have that trajectory, create a way to understand somebody went into an adverse event. What was the situation that led to that? And how did they recover? That also recovered, that other trajectory. There's another point, inflection that happened, that I went from a disease state to a healthy state. Why did I end up getting healthy? Why the other person did not? So a lot to learn here from these. And obviously you can think about incredible methodologies in data science, right? Network, graph aspect, et cetera, to try to connect the dot, maybe new science, a way to analyze that kind of data. So let me now give you an example of some of the things we are doing, not obviously with that vision yet, because this is still a new work, but I'll talk to you about how we started to tease out certain aspects. I mentioned to you the aspect of lifestyle, environmental, and biological determinant. These are all stressors on the body. We know very well the effect of, let's say, diet, exercise, sleep, light, circadian rhythm aspect, noise. We know about pathogens, from the COVID. I mean, how can we not know about that? We know genetics. How is it really affecting, your body? And what is it doing to these organs? So here, I'm going to give you, it's hard for me to study everything. Right now, we're doing a lot of these things in very much isolation. And maybe this is the problem we have in terms of getting funding to do that global picture. But I'll give you an example of exposure to stress. And what is stress mechanistically doing? We know it's bad for you, but what is it really doing? What are the things that are being modified? And what are the circuits that are being disrupted? And you'll see some of the tools we are using to do this. So psychological health and cardiovascular disease, very well documented epidemiologically. It's a huge emphasis that continues up to today, from the American Heart Association, as well as, other groups recognizing this as a risk factor, as important as high blood pressure or cholesterol or other aspect. We know that it leads to multiple cardiovascular diseases, not only, heart disease and myocardial infarction or heart attacks, but stroke, metabolic disease, etc. We know that there are multiple axes that are being disrupted there. So it's really a very interesting model for us to study and to evaluate. Let me make some definition. Obviously stress is something uncomfortable. There's an emotional experience that has been accompanied by some changes biochemically, physiological, or behavior. I'm specifically going to talk about chronic stress exposure. So this is something that is put over a prolonged period of time, and it's well recognized, again, that it's linked to disease, including cardiovascular disease, as well as brain, and even cancer. And there's obviously things that are happening biologically that this breaking down this homeostasis and progressing to disease. This is very different than acute stress exposure. I'm actually now under an acute stress environment. Public speaking is very well recognized to be that. If I check, my heart rate is more elevated than at rest. Maybe when you start asking me questions, I'm going to get a little bit more. But after that, I'm going to go back to my normal. I'm able to. We're all of us are well trained here to be able to do this. So that's on the acute aspect. There are very interesting things to study on the acute, and then we have a program evaluating, especially in animal models, looking at acute exposure. But I think the aspect of chronic exposure are incredibly well recognized and how bad they are. I don't have to cite to you people exposure to during time of wars, during attacks in terms of the different things you experience. I grew up in a war country. I have not measured anything on myself, but maybe it made me more resilient in general since I didn't suffer any long-term effect. Maybe they're more positive in my aspect, but we know a negative aspect. We experienced it. I experienced it myself during the WTC 9/11 attack. New York City reminding me of Beirut, Lebanon, where I grew up when I was a young child. And obviously long-term effect of the exposure, not only from the chemical exposure and the deleterious environmental exposure, but they have been other aspects related to stress and PTSD. Mount Sinai actually is one of the centers that is study and continues to study this on the healthcare, on the first responders that included obviously the fire, the police, and other responders. So that's very well documented, and it's clear the cumulative risk that is there. And we know also that there are certain areas of the brain that are targeted and disrupted during exposure to stress. We know, stress can come from different origins, right? And then that affect multiple areas within the brain. And I'm going to focus, although we do study the brain as a whole, because we have very powerful imaging methodology. People who know MRI know today that we can really get very much all the circuitry mapped within the brain metabolically, as well as, circuits that are functional or dysfunctional. I'm going to highlight our initial work that is, or initial, I would say, data that's focused on the amygdala, which we have two of them, the little nuts within the brain. These are the fear, centers that control that aspect. There have been well-documented work using metabolic imaging. Although I'm an imager, but I'm going to go over, not talk too much about imaging methodology other than results. We can measure somebody's metabolism by injecting a glucose analog. We use this today for cancer imaging to look at tumors, how actively they are metabolically. Obviously, the brain is also very metabolically active, and we can evaluate, these different regions, how they are. And now looking at non-human primate, looking at the relationship, on this axis is the anxiety scale. And then you have the uptake within the amygdala with FDG, showing a very active amygdala. So when you are exposed to that stress, that's what you want. You want that to be ignited, because that amygdala is going to orchestrate to you, I saw this bear, I need to run really fast. So this is really that flight response that you get when you're exposed. So your amygdala is controlling that signal. There's also work, again, in this population work, looking at now relationship between amygdalar activity and cardiovascular disease. You can measure in somebody's carotid artery. Carotid artery, connects to you from your heart to your brain, very important vasculature, and deposit of cholesterol or inflammatory cells, is a marker here of atherosclerosis. So with ultrasound, you can measure that thickness. It's not a useful tool in a single patient. It's a population thing, and they showed that people that have high activity of their amygdala, they have more intima thickness in cardiovascular disease. And then they also relate that to blood markers. If you have cardiovascular disease, it's not only high cholesterol or risk factor related, but we know that there's a lot of inflammatory cells within the blood. So they're able to correlate amygdalar activity with blood markers within that. So the stage is being set, but this is more of a different data point, and we put together a program to try to tie these things together, and using novel methodology not only imaging tools, which I'll explain to you, using PET, positron emission tomography, and magnetic resonance imaging, where we can simultaneously measure the brain, the vascular, and the heart, but also trying to use, inflammatory markers and blood markers to trying to unreveal what's mechanistically ongoing in there. So we have a hypothesis that I skipped here that came from animal model that shows that the more you have cardiovascular disease or inflammation within your vasculature, that not only leads to deposits of these plaques within your vasculature, but your macrophages or inflammatory cells being driven out from the bone marrow are extremely active. So this is called myelopoiesis. So there's an incredible turnover and activation of the bone marrow, as well as activation of the spleen, which I skipped a little bit. So there's a whole continuum that is leading from the stress, from something that is inputted to the brain, that leads to the heart being mediated by your immune system. So that's a discovery that we and our colleagues have made in animal models, and we started to translate that into human here application. So this is, I'll lead you a little bit to it, but I'm showing you two different patient type. One patient that have no cardiovascular events if you follow them over time, and another one that have had a cardiovascular event, and we have also data on what's happening in their brain, in the amygdala, what's happening in their cardiovascular system, what's happening in their bone marrow. It's actually the first demonstration of this brain vascular bone marrow connection. And we showed that in these two patient groups, the one that had subsequent cardiovascular event had amygdala activity that is enhanced, deposit of inflammation within the vasculature, and an incredibly active bone marrow where these resident macrophages, inflammatory macrophages are there. So that's point number one. Point number two, these patients, we had a full cognitive assessment, and we can, with instrument very well established in psychiatry and psychology, you can come up with what's called perceived stress scale. And we correlated the scale of stress from the questionnaires with the inflammatory marker, something that was demonstrated early before. But our discovery of linking now the amygdala activity to the vascular inflammation by imaging, as well as the perceived stress scale. That's actually our contribution to this field. This was published in the Lancet a few years ago, and that's led to this program that we have ongoing now, where this is a summary, not published data yet. This is being submitted as we speak, where we now have, we launched this prospective study, taking people that have been exposed to trauma and have been classified by the psychology as have post-traumatic stress disorder, using their instrument and psychological cognitive testing. Taking another group that has been exposed to chronic stress, but have shown to be resilient from the instrument. So that's a very important group. That's called the trauma control. Actually, probably the most interesting group there. Why is they resilient? Same thing. Why is this person lean? And then obviously we have the control. And we are looking at here, this is now looking at the amygdala and looking at other areas in the brain, like the prefrontal cortex, which also is responsible for orchestrating and managing this exposure to stress. You can see almost a dose response between the different groups in terms of activation. The most active would be the people with stress, trauma control less, and the one obviously normal. And then we've also mapped, and I'm going to skip a little bit the different distribution of circuitry within the brain using diffusion tensor imaging, which is used to look at people with stroke, but also to map the stress within the brain, to map the circuit within the brain, and showing how in PTSD these circuits are disrupted Well, in the other groups, the circuit is actually not, it's integral, it's to the normal. So beautiful way to try to get these multi-organ aspects. As I mentioned, also, we've run, parallel studies trying to tease out other lifestyle aspects. And these are some preliminary data of some of the work that we have done. We looked at the aspect of exercise, you're looking at data in the brain and then following people longitudinally and trying to really find the connection between activation of the brain and exercise, and how positive exercise is on your amygdala compared to people. And this needs to be further testing. We are hoping to launch an exercise study trying to understand this better and what type of exercise would be useful to you, etc. And obviously, we looked at the aspect of alcohol intake. That's an interesting finding. I'm not sure what we're going to do this, but obviously there is a moderate alcohol have been good actually to you, to your brain. Obviously, high will not be very good, other than your liver, but there's obviously things that in your brain aspect is not very good. I was just talking to Nick, using my wearable aspect, how, although I'm from France, I like to drink red wine, but it kind of showed me how even one single drink of wine, my next day recovery signal coming in from these wearables is always detrimental. So we'll see. But do you take the joy of life? I don't know. We'll have to see. Okay. So let me now, topic number 2, right? So now, how are we hope that we can come back to that full picture of assessment? And we know, obviously, the integration of wearables and how they are now ubiquitous almost, and nobody leaves home without their smartphone, how more and more people are, wearing, smart watches or wearing some kind of device. Not all of them obviously are widespread, and there's a lot of more work that needs to be done here. But this definitely is an area that seems to have an impact, at least from an adoption point of view, and it's up to us to figure out how useful it's going to be or not. But conceptually, especially you can attest to that. You are a data institute. The more data you have, hopefully the more and the easier your problem solving might be. I am guilty as charged. I come at it from a very enthusiastic person who likes to measure things. It motivates me to be very active, during the day and in life. But I also try to, n equal to 1 kind of methodology on myself. I told Nick, the only impact I've seen so far, it did help me, other than maybe not drink as frequently, but also improve my sleep habits. But that's very personal. I mean, it's really, I'm gaming myself. It's the way I operate. It's responding well with me, but even if I disconnect myself today, am I going to change my workout habit? I don't think so. I like it. It is giving me a dopamine hit, and I like to do that. But it's nice to see numbers. Some people like it. Some people find it overwhelming and useless. But we hope to be able to leverage, these markers for research purposes and maybe for clinical care. So one example, we know, and this work is Michael Schneider from Stanford, who I'm sure either you invite him or you will invite him in the future. I mean, he's well known to put together, omics studies to try to measure on a cohort of people, different lifestyle aspect and discovery. So we know that there are many processes that get changed during one of these lifestyle aspects, like exercise. What type of exercise is useful to you? Should I do like I did this morning? I went to one of the CrossFit boxes here, Peak 360, and it was mainly a HIIT type of exercise. Do I do this only, or should I be doing other things? I think it's a personal thing, unless we measure and we see these changes. I mean, there's so many metabolic things that change when you do these things. And maybe we should be able to design the best exercise regimen for somebody, either for a lifespan or for treating, chronic diseases, etc. Same thing in nutrition. I mean, we know this. I mean, actually, there's so many things being told about nutrition. I don't understand any of them. Should I eat in the morning, or should I fast and maybe eat at noon? Should I skip this? Should I eat peanut butter, or should I not eat? So all these, they are changing. I mean, I don't know if some of you have tested the glucose monitors for fun, but you can see the spike. I mean, you eat a banana, you get that spike. Okay, you can live with that spike, but maybe you shouldn't. Maybe you can design maybe new type of food or supplements to tone down the spike. For normal people, maybe it's okay, but maybe if you have some diseases. No. So I think we have a lot to learn. That's why I like to measure, and maybe let's learn something from that. But let's not ignore some of the things that your body, I mean, I mean, I'm taking this from somebody who said, your body is revealing secrets to you. But if you don't listen, it's not going to tell you. So there may be something there. Obviously, we know glucose monitoring, had a huge impact in practice. So that's, but we'll see for the general public if it would be useful or not. So we actually, when COVID came along, I mean, like a lot of people, and but we used that opportunity to test some ideas that we had in planning. I created a cohort for us and ways to do this. And we had some philanthropy also to deploy some of these tools very quickly. So I'm going to talk to you about what we called the Warrior Watch program or study. And it was intentionally put together to equip people with an Apple Watch. We wanted to be, single modality, although we are not happy with, I don't even wear an Apple Watch because they have issues. But we wanted to get into that and to do two things. Use some of the physiological parameters that it brings. And we were very much big on heart rate variability to see if this would be useful to predict somebody's disruption due to infection, and COVID being the one that was the most on the table. And obviously the aspect of stress and exposure to stress, HRV, as you know very well. Skip this. Maybe I'll go here. Yeah, very obviously a very strong measure of looking at variation over time between your heartbeat. It is a testament, or it is a picture of what's going on to your autonomic nervous system, both sympathetic, parasympathetic. And it's really there, regulates your heart rate, blood pressure, etc. So people have been very interested in heart rate variability as a way to look at exposure to stress, but also exposure to diseases. The WHOOP, which is a WHOOP, I don't have any connection with them. They don't pay me, although I did grandfather their membership since I went in early. They rely, their whole model that is an HRV based measurement that looks at your heart rate during the day, what happened at night, and comes up with a strain score and recovery. So it's very, although they claim they are using other things, but I do think HRV is where they are doing the most. So let me go back to this. Yeah, so we know that these devices exist, quite a bit of them. They do a lot of things. Heart rate, heart rate variability, they get you steps. Some of them do SpO2, temperature, sleep, and etc. There's a lot of variety. Not all of them, I think, are well validated. The sleep aspect, still needs more work. I mean, obviously, and there's so many new things, which I'll talk about in the near future. The biggest impact that we've seen, and actually from a research and research design point of view, the aspect of using wearable that is deployed in mass people, and to do clinical trials in this way, that using people's devices, and people and Apple and others have shown that they are able to get validated and products looking at the smartwatch to identify atrial fibrillation. So more to be done there, right? And not everything that the watch is telling you is useful. So we'll see. The other aspect that I mean, I'll come back to the Warrior Watch, that in a way for us, we were already putting together a platform, a digital platform. We called it eHive. And that platform, the biggest thing for us was to be able to do clinical trials remotely. So e-consenting was a big thing, and the aspect of doing this electronically, we had to go to the IRB. But suddenly when COVID come, everything went through and it got approved, so now we have a platform to do that, consent electronically. But also, we were also at the same time working with data use agreement with several companies, including Apple and others, to give us access to the data. Not all of them play well with us, and not all of them are nice, and some of them are, black box. Some of them want you to pay a lot of money for your own data. So a lot of ethics issues, I think, there to be dealt with. But at least we have a platform that we can ingest with the major vendors now, the data. And then obviously we're interested in this whole full integration. We've also helped, and my colleague, I have to say, I'm not responsible for this, my colleague at the Hasso-Plattner Institute were able to also design tools to the institution itself to put together a resilience center during COVID, and they continue up to today, where you built a lot of the mental tools to assess and then some instrument and coaching for that aspect. So digital health, is interesting. From a research point of view, I think obviously is impactful. And now we'll have to see clinical care is a different story. Okay, so let me go back to the Warrior Watch. So yeah, so the Warrior Watch was taking the Apple Health Kit and now connecting it to our eHive, where we design now questionnaires very much with a user experience that is realistic, not the long form, but short form questionnaires about exposure to COVID and symptoms, as well as other psychological tools. And we have a great researcher, Laurie Kiefer, who's expert in working on psychological well-being with questionnaires, looking at resilience, stress, optimism, emotional support, quality of life. And these are very strategically deployed within the app. Either on a daily aspect, you ask certain question, on a weekly, you ask others, to be able to tease out, some of the mistakes you may make, or some of this. It's an interesting science that she has perfected in her work. And then obviously taking the physiological measurement from the Apple Watch. Mainly, again, our focus has been on HRV. Also working with our data science group, we looked at what would be the best way to analyze some of that data. And then we came up with this, methodology that's, published, in the past, looking at the amplitude, the acrophage, the period, and the meso. This is a really nice way to which I was not familiar with, but very strong in terms of fitting the data and looking at subject to subject changes for this HRV. There are a lot of ways you can analyze HRV. People who are expert in it can attest to that. So we found this way, the circadian pattern analysis, to be extremely helpful. So very quickly, we deployed this in our healthcare workers. So we focus on Mount Sinai healthcare workers, people who have been working either part of the deployment during COVID, but some of them were, working from home. Some of them, were not doing clinical care, but obviously were part of the healthcare aspect to the institution. And we had COVID testing on some of them. And we demonstrated that there are different patterns. And you can see on the left side, that healthy patterns of HRV distribution, and then how it changed 1 week before, you basically shown any symptom. So we are able to detect infection or changes in that HRV signal 1 week before somebody's symptomatic, and how the recovery after 1 week. It doesn't mean it's COVID. It could be any infection, but obviously in the case of how this can be deployed is in the case of a pandemic, where you want to err on the side of caution. All you need to tell the person, look, we think you maybe COVID positive, why don't you go get a test? So we can catch you before you deploy these symptoms. Very important, obviously, and we put this together, which we never ended up deploying. We should have almost did it during the variant changes, but we have it now available in real time. So be able to, we have a machine learning now also algorithm that runs in real time for this. The other aspect that I was very interested in is to look at emotional stress and to study that, to see how this is affected, how HRV signal is affected during that. And also, since we studied with the psychological instrument, we studied the people who had high stress on the score compared to people who have been resilient. And we discovered, obviously, that the people who are resilient, you know, they were most of the time were the one most experienced in clinical care. They're used to that aspect. The one who were really, you know, freaking out were the resident who were deployed, and also some doctors who were seeing patient in clinics and never been deployed in an aspect of a crisis situation. So this is very interesting because you could deploy now and start changing your resource allocation and human capital if you are able to physiologically measure this and assess that aspect. So again, maybe we'll utilize some of these in the future, etc. And then finally, I wanted to do is what we call now the warrior shield. You know, how can we deploy digital interventions to see if we can modify that signal, that HRV signal. So we took one, I mean, there are many ways you could do this, and we took one technique which is called the heart math. This is a well-established technique used in many clinical studies looking at anxiety. It's a biofeedback methodology, and they have a sensor with a PPG on the ear. They can get heart rate variability this way, and then they have an app linked to it with some instruction on breathing exercises to come at the resonance frequency. And this way you have this HRV and you become trained into doing this. And, you know, let's say, you know, you're under stress, etc. You learn now suddenly. I mean, there was just a paper yesterday I read in Cell looking at different ways of respiration, you know, box respiration. There are different protocols. And I think they are extremely effective. You just have to learn how to use it. This is a very easy method because it's visual. You know, clip it here. It doesn't require a lot. It's 5 minutes a day for 5 weeks for training. And then we evaluated it 12 weeks after. I don't have all the data with me, but it looks pretty positive in terms of modification and assessment. Okay. So now, you know, the story, all of it is not complete. I do think we are seeing, as I said, we need better ways to integrate data with this mobile app platform, but we're also seeing incredible new devices, you know, beyond the consumer, beyond what Apple, Fitbit, Garmin, and that are really going to the general public, but we're starting to see companies bringing in novel technology, you know, either optical methodologies, integrating AI, etc., to try to detect, you know, signal better. But there's also other type of electronics. And we invested in a laboratory, you know, with the recruitment of YSK, who is expert in the soft bioelectronics. So let me talk to you about a little bit what we've been doing. So these are electronics. These are like, you know, on a very, you know, deformable circuits, and that can be functionalized as well as done in the laboratory using really, you know, tabletop equipment. You don't need the clean rooms anymore. The fabrication material science of that evolved quite a bit. And you can equip them with all kind of different sensors and miniaturization that can be placed all over the body. So they can be made into a bracelet, which you know, we're working on a Mount Sinai health band. I'm hoping to raise some funds to do this. If Sinai doesn't want to do it, maybe somebody else will put their name on it. Happy to give it to them. But, you know, but more importantly is you're able to place that patch in multiple areas, either in the setting of, you know, of let's say, you know, where you're in an operation room or at home, depending on what you are measuring. If you're looking at things related to sleep, put it on the forehead, sternum patch, etc. So this is an incredible platform that we feel that will get us much faster than relying on a commercial entity. Of course, we will be missing certain technologies that are proprietary or we're not expert in, but I do think it does give us, I would say 80%, maybe 70% of what we can do ahead of every people, and then modify it and test it also in the clinic very, very fast. Okay, so this takes me to the end of my talk. Sorry, I spoke too much, didn't realize that. That shows you, I skipped certain things that we're working on, which will be, novel imaging probes, novel immunotherapies, but the top, layer is what I discussed here, how they go to whole person research, mHealth, novel sensors, and then using AI technology to do this. Thank you so much.
That's all right. We still have time for questions.
Good, thank you.
And beginning, I think it's only fair with people. But also long enough, I'll be able to ask the first one. Yes, please.
So I have a question. So bringing it to talk, as these consumer electronics get more and more advanced and we take care of with machine learning, they're going to be able to predict diseases. At what point will these tech companies have an obligation to tell the users that they might have generative disease or something that's considered?
I mean, that's obviously regulated by the FDA, right? So once you start bringing these devices from consumer to aspect related to care, then you obviously have to go through a whole different regulatory and validation.
So even if they are consumer, I know that the FDA has.
Yep. You are not allowed.
So you're not allowed to, even if you know.
Remember 23andMe, right? 23andMe, which is genetic testing to the general public. They were stopped, right? They were, forget, the FDA told them, cease and desist. No way you're going to go forward because you are now starting to infringe on making a recommendation related to disease. So there's no way the FDA is going to let them that. What I think needs to happen, we need to start putting together, right now it's a little bit Wild West. We need to put together guidelines. We need to put together pathways for these devices to either go from consumer to become, healthcare a grade aspect. Yeah. Right now, these companies are saying, oh, it's consumer. Yeah, but we're not involved, so yeah. Yeah. But the precedent is there that you cannot do that. So yeah. But I think there is enough interest outside the consumer. Some companies are interested to create a healthcare specific devices, but they have to go through a different process. And we still need to come up with the rules of engagement, from an ethical point of view, from a regulatory point of view, et cetera. Yeah. 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 If it's FDA approved, I mean, the Apple Watch for patient at risk for atrial fibrillation, I mean, you can do that. Yeah.
The insurance will cover it. Yes, please.
Well, yeah, right. That's a different battle there. Nice. Absolutely. Oh, yeah, good. I think the better signal, although we have MRI, we have structural MRI, and we can map the whole volumes within the brain. However, I think the signal from a metabolic point of view is much better with PET, and metabolic information is much better than just looking at the size of that nut. Yeah. That's beautiful. I like it a lot because I do think it is related. It's a lifestyle stressor exposure. And I know that from looking at heart rate variability and looking at other aspects in terms of activation of the myelopoiesis or interruption to that, that there's definitely relationship between that sleep and the immune system. We have animal data, tons of animal data looking at that. Yeah. Yeah. Oh, that's very interesting. There's a lot going on in the left and in the right. I don't know, but we're not the only one showing that. Many people have shown this. So that's yeah. So you have to look at both, but we are seeing somehow the left side. I'm not a neuroscientist, so I don't, but there's more on the left side than on the right. Good point. Yeah. Thank you. Yeah. Consistent with the literature and with the finding. Yeah.
There is one question online from a colleague in our cell biology department.
Yeah.
Chapman, he was asking about some of the data management and privacy issues.
Right.
Where there are a number of systems here, and what I was struck by was the relationship between behavioral health and other systems.
Yeah.
Is that how are you guys addressing that?
I mean, this is still an unsolved problem, right? I mean, we obviously worry a lot about data security and HIPAA, et cetera. We're working under, a research environment, but we still are looking. I mean, that's why people like you and others, in that ethics aspect, right? Looking at, how in the future are we going to be able, what's the best way to handle that data? Yeah.
To do it in such a way that advances the science.
Yeah.
Well.
Yeah.
Yes, please.
Thank you for a wonderful talk.
Thank you.
I'm actually a physician scientist.
Great.
Yeah.
Excellent. Yeah, a lot of stuff we're doing in kids now with these sensors. Yeah. Yeah, I know that.
With the EHR,
Mhm.
and also the different systems, for example, we landed on Epic, where I work in Jackson, CERN,
Ouch.
and getting this type of data into any type of
Like an OMAP type. Yeah. Yeah. Yeah, I am not an expert in this, but obviously mapping to some kind of a ontology, et cetera, would be very important. And there's a lot of active research in the space, which I think more needs to be done there. It's not an easy problem. I mean, you guys know that's a data scientist. So but that could help in the future, the aspect of, having different EHRs and mapping them to a single kind of aspect. We, unfortunately, at Mount Sinai, I think we have 9 hospitals. Only one of them is not on Epic, but all the others are on Epic. So fortunately, from our point of view, that makes it a little bit easier, but it doesn't mean it's a problem solved. It's a lot of issues. Yeah, but mapping to OMAP, to the OMAP or others. I mean, there's not only OMAP, there are other type of standard. Yeah, but that's a huge research area, and we hope that other people will work on it and it solves a problem for us. Yeah. Yeah. Correct. Yeah, absolutely. Yeah. 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 I mean, fortunately, maybe turn to the data scientists, there are ways to correct for this and to normalize. And that's a nice thing about, AI, ML, techniques, et cetera, that dealing with that longitudinal data, you don't need to homogenize always. You can still make inferences. There are ways to correct for this. So, but again, what you're asking, these are great science questions. People still working out ways to do this, but I don't expect them to be unresolved. Yeah. Yeah.
I detect the need to have a seminar that lasts for several more hours. But there are some.
Happy to come again.
But in fact, I assume you're also willing to linger for a few minutes after we.
Oh, I'm here. Yeah,
we're
here.
It's after 5.
So
So maybe you get the first question after we draw to a conclusion, and we get to thank Professor Dr. Fayad for a brilliant presentation and contributing to our data scientist and data citizen mission. Thank you so very much.
Thank you again. Thank you very much. Appreciate it.